Jai Hind, everyone. Let's continue with part 2 of chapter 5 from NCERT Class 11th, Physical Geography, that is geomorphic processes. So, in the last video, we have completed till weathering. Now, let's continue with the other topics. So, the first topic under this video is mass movements. These movements transferred the mass of the rock debris down the slopes under the gravity influence. So, what is the reason for mass movements? These happen under the direct influence of gravity. That means air, water, or ice do not carry debris with them from place to place. But on the other hand, the debris may carry with it air, water, or ice. So, what is being told here? That the agents may not carry debris, but the debris may carry these agents along with it. The movements of mass may range from slow to rapid, affecting shallow to deep columns of material and include creep, flow, slide, and fall. So what is happening? These movements under the influence of gravity can range from slow to rapid and affecting shallow to deep columns of material. And these movements include what? Creep, flow, slide, and fall. As we move forward, the speed under each movement increases. So creep is the movement that has least speed, whereas fall has the highest speed. Gravity exerts its force on all matter, both bedrock and the products of weathering. So gravity has influence not only on the products of weathering but also on the bedrock. So, weathering is not a prerequisite for mass movement, though it aids mass movement. So, as mass movement has effect on both bedrock and products of weathering, weathering is not a prerequisite, but if there is weathering on which the mass movement is happening, then it will help the mass movements. Mass movements are very active over weathered slopes rather than over unweathered slopes. So, mass movements are active on weathered slopes where weathering is happening. On that, mass movement is very active, whereas over unweathered materials, it is less active compared to weathered slopes. Mass movements are aided by gravity, and no geomorphic agent like running water, glaciers, winds, waves, and currents participate in the process of mass movement. So, in mass movements, there is no role a geomorphic agent plays. It is purely based on or purely aided by gravity. That means mass movements do not come under erosion, though there is a shift of materials from place to place. So, how do geomorphic agents help? They help in shifting of the material from place to place. But in mass movements, and although there is no erosion, although there is a shift, they are not included under erosion. Materials over the slopes have their own resistance to disturbing forces and will yield only when force is greater than the shearing resistance of the materials. So even though when the mass movement is happening, the material or the slopes will have their own resistance. But when the force exerting on them exceeds the resistance they put against the force, then only it takes place. Weak unconsolidated materials, thinly bedded rocks, and faults, steeply dipping beds, vertical cliffs, or steep slopes, abundant precipitation, and torrential rains, and scarcity of vegetation, etc., favor mass movements. So, these are all the conditions that favor mass movements. Several activating causes precede mass movement. So there are some factors that precede mass movements, like removal of support from below to materials above through natural or artificial means. So this is the first condition that can precede mass movement, like removal of support from below to materials above through natural or artificial means. Next, increase in gradient. So if the steepness increases, it will help in mass movements. And next one is overloading through addition of materials naturally or by artificial filling. So overload or heavy burden on the materials can also aid mass movements. Next, Overloading due to heavy rainfall, saturation and lubrication of slope material. So rainfall will be another major factor that can aid mass movement. And next, removal of material or load from over the original slope surfaces. Sixth one is occurrence of earthquakes, explosions or machinery. And next, excessive natural seepage. So excessive natural seepage also, it can precede mass movement. And heavy drawdown of water from lakes, reservoirs and rivers, leading to slow outflow of water from under the slopes of riverbanks. So this is also a condition. And next, indiscriminate removal of natural vegetation. So these are all the activating causes that precede mass movements. And now we have a certain forms of movements. Under that, the first one is heave. What is heave? Heaving up of soils due to frost growth and other causes, and flow and slide. These are the three forms of movements. What are the three for? That is heave, flow and slide. The relation among different types of mass movements and their relative rates of movement and moisture limits. Now let's see what are landslides. These are relatively rapid and perceptible movements. So what are the two features of landslides? These are rapid and perceptible, means they can be seen or they can be noticed. The materials involved are relatively dry. So in a landslide, the materials that are being transported are relatively dry. The size and shape of the detached mass depends on the nature of discontinuities in the rock, the degree of weathering, and the steepness of the slope. So the materials that are being transported depend on the nature of discontinuities in the rock, degree of weathering, and the steepness of the slope. Depending upon the type of movement of materials, several parts are identified in this category. So depending on the type of movement of materials, there are certain categories under landslides. So in that, the first one is slump. What is slump? Slump is slipping of one or several units of rock debris with a backward motion with respect to the slope over which the movement takes place. So what is slump? So if you see, this is a big rock that is being displaced. It will happen in a backward motion. So it will this way. So it gets removed in a backward rotation. So this is why this is called slump. It is one category under landslide. Slump is slipping of one or several units of rock debris with a backward rotation with respect to the slope over which the movement takes place. And the next one is rapid rolling or sliding of earth debris without backward motion of mass is known as debris slide. So if there is a backward rotation, it is called slump. If there is no backward rotation, then it is called rapid rolling or sliding, which is known as debris slide. So in debris slide, there is no backward rotation of debris. And the next one we have debris fall is nearly a free fall of earth debris from a vertical or overhanging face. So a debris fall over, if it is the vertical plane from which the debris is being fallen, then it is called a debris fall. Sliding of individual rock masses down bedding, joint and fault surfaces is rock slide. So in rock slide, individual rock and it's sliding. Then it is called rock slide. So these are all the categories. First one is slump. Next one is debris slide. And next we have debris fall and we have rock slide. Over steep slopes, rock sliding is very fast and destructive. So over steep slopes, as the gradient is more and the influence of gravity will be more, so rock sliding is very fast and destructive. See here we can see landslide scars in Shivalik Himalayan ranges near the river Sharada at Indo-Nepal border. Slides occur as planar failures along discontinuities like bedding planes that dip steeply. So what is the where do the slides occur? They occur along discontinuities like bedding planes that dip steeply. Rock fall is free falling of rock blocks over any steep slope, keeping itself away from the slope. So what happens in rock slide? It it will be in contact with the steep. Whereas in rock fall, there will be no contact between the rock and also the slope. So this is the basic difference between rock fall and rock slide. Rock falls occur from superficial layers of the rock face, an occurrence that distinguishes it from rock slide, which affects material up to a substantial depth. So what happens in rock fall? It occurs from the superficial layers of the rock surface. This is the basic difference between rock fall and rock slide also. Now, in our country, debris avalanches and landslides occur very frequently in the Himalayas. There are many reasons for this one. One, the Himalayas are tectonically active. They are mostly made up of sedimentary rocks, unconsolidated and semi-consolidated deposits. The basic reason is they are the young folding mountains, and the formation of Himalayas is still in continuation till today. So they consist of sedimentary rocks, unconsolidated and semi-consolidated deposits. The slopes are very steep. So in Himalayas also, the slopes are very steep. But compared to the Himalayas, the Nilgiris bordering Tamil Nadu, Karnataka, Kerala, and the Western Ghats along the west coast are relatively tectonically stable. So compared to Himalayas, the Western Ghats and Nilgiris are comparatively stable and are mostly made up of hard rocks, whereas Himalayas are made up of sedimentary, unconsolidated, and semi-consolidated rocks. But still, debris avalanches and landslides occur, though not as frequently as in the Himalayas in these hills. But why? Why do debris avalanches and landslides occur, although they are tectonically stable and made up of hard rocks? Because many slopes are steeper with almost vertical cliffs and escarpments in the Western Ghats and Nilgiris. So what happened? The slopes are steeper in Western Ghats and Nilgiris. Mechanical weathering due to temperature changes and ranges is pronounced. So although they are tectonically stable and hard rocks, mechanical weathering can induce the disintegration of the rocks, which is due to the temperature differences. They receive heavy amounts of rainfall over short periods. So there will be heavy rainfall during southwest monsoon, and that will be over short periods. And also, so there is almost direct rock fall quite frequently in these places, along with landslides and debris avalanches. So what happens? There is a quite a good frequency of rockfall occurrences along with landslides and debris avalanches. So this is about mass movements that is under one of the denudational processes. And the next one we have is erosion and deposition. So what is the last step in erosion? As we studied, under erosion, the weathered particle will be carried out by the geomorphic agents, and when the energy decreases, when the energy of geomorphic agent decreases, at the end they start getting deposited. So erosion and deposition are a combined process. Erosion involves acquisition and transportation of rock debris, where when massive rocks break into smaller fragments through weathering and any other process, erosional geomorphic agents like running water, groundwater, glaciers, wind, and waves remove and transport it to other places depending upon the dynamics of each of these agents. So what happens? Geomorphic agents aid in erosion. Abrasion of rock debris caused by this geomorphic agents also aids greatly in erosion. So, I'm sorry, due to the abrasion of rock debris. So, what happens in abrasion? The materials get plucked up by the rock debris. So, this also helps in erosion. By erosion, relief degrades. That is, landscape is worn down. That means, though weathering aids erosion, it is not a precondition for erosion to take place. So, weathering aids in erosion, but it is not a precondition for erosion. In this mass movement also, we did the same thing where it says it can aid, but it is not a precondition for mass movement. Here, weathering is not a prerequisite for mass movement, though it aids mass movement. So the same thing is applicable for erosion also. Weathering aids erosion, but it is not a precondition for erosion to take place. Weathering, mass wasting, and erosion are degradational processes. It is erosion that is largely responsible for continuous changes that the Earth's surface is undergoing. As indicated in figure 6.1, denudational processes like erosion and transportation are controlled by kinetic energy. So what are the driving forces for erosion and transportation? It is the kinetic energy. The erosion and transportation of earth materials is brought about by wind, running water, glaciers, waves, and groundwater. So these are all the agents that help make erosion and transportation get going. Of these, the first three agents are controlled by climatic conditions. So what are the three that are controlled by climatic conditions? Wind, running water, and glaciers. They represent three states of matter, that is gaseous, liquid, and solid states respectively. The work of the other two agents, that is waves and groundwater, is not controlled by climate. In case of waves, it is the location along the interface of litho and hydrosphere, that is coastal region, that will determine the work of waves, whereas the work of groundwater, it is determined by the lithological character of the region. So it depends upon the rocks. If the rocks are permeable and soluble and water is available, only then karst topography develops. So karst topography is something that is a result of action of groundwater. So we'll study in detail in the next chapter. Deposition is a consequence of erosion. The erosional agents lose their velocity and hence energy on gentler slopes, and the materials carried by them start to settle themselves. In other words, deposition is not the actual work of any agent. The coarser material gets deposited first. So the material that has more weight or mass get deposited first, and the finer ones later. By deposition, depressions get filled up. The same erosional agents, that are running water, glaciers, winds, waves, and groundwater, acts as aggradational or depositional agents. So first, in the beginning of the process, they act as erosional agents, and in the last, the same agents act as depositional agents also. What happens to the surface of the earth due to erosion and deposition is elaborated in the next chapter. So we'll study about different landforms in this next chapter. So this is about erosion and deposition. Now the next topic is soil formation. You see plants growing in soils. You play in the ground and come into contact with the soil. You touch and feel soil your clothes while playing. Can you describe it? So what is a soil? Soil is a dynamic medium in which many chemical, physical, and biological activities go on constantly. So in soil, chemical, physical, and biological activities go on constantly. Soil is the result of a decay, and it is also medium for growth. So how does soil form? It basically starts with the dissegmentation of the rocks, and then chemical actions occur on it, and due to the biological activity, it results in the formation of soil. So soil is a result of decay, and it is also the medium for growth. It is a changing and developing body. It has many characteristics that fluctuate with seasons. So the characteristics of soil fluctuate with seasons. It may be alternatively cold and warm, or dry and moist. So the characteristics of soil depend upon the seasons. Biological activity is slowed or stopped if the soil becomes too cold or too dry. So what is the condition for biological activity? That the soil should be warm and moist. But if it becomes too cold or too dry, the biological activity will stop or slow down. Organic matter increases when leaves fall or grasses die. Now let's see the process of soil formation. Soil formation or pedogenesis. So what is pedogenesis? It is the process of soil formation. Depends first on weathering. So what is the factor on which soil formation depends? It is weathering. It is this weathering mantle which is the basic input for soil to form. The weathering mantle is basic input for soil to form. First, the weathered mantle or transport deposits are colonized by bacteria. So first the bacteria starts acting upon the weathered material and other inferior plant bodies like mosses and lichens. Also, several minor organisms may take shelter within the mantle and deposits. The dead remains of organisms and plants help in humus accumulation. So this dead and decay matter helps in accumulation of humus. Minor grasses and ferns may grow later. Bushes and trees will start growing through seeds brought in by birds and winds. So when these bushes and trees grow, these plant roots penetrate down. Burrowing animals bring up particles. Mass of material become porous. This penetration by both plants and animals make this material more porous and sponge-like with a capacity to retain water and to permit the passage of air. And finally, a mature soil, a complex mixture of mineral and organic product forms. So when the soil becomes porous, it has the capacity to retain water. It gets sufficient air, so which can help in the maturement of soil. So that is how a mature soil is formed, which is a complex mixture of mineral and organic products forms. So what is pedology? Pedology is soil science, and a pedologist is a soil scientist. Now we'll see the factors that are responsible and that control the formation of soils. Under that, the first one is parent material. Parent material means the parent rock from which the soil is being formed. That is called parent material. So is it an active or passive factor? Parent material is a passive factor. Parent materials can be any on-site weathered rock debris or transported deposits. Soil formation depends upon the texture and structure as well as the mineral and chemical composition of the rock debris. So soil formation depends upon size of the debris, that is its texture and its structure, also the composition of the rocks. Nature and rate of weathering and depth of weathering mantle are important consideration under parent materials. So under parent materials, what are important? Nature and rate of weathering and also depth of weathering mantle. These are important under parent materials. There may be differences in soil over similar bedrock, and dissimilar bedrocks may have similar soils above them. So this is also possible. But when soils are very young and haven't matured, they show strong links towards the parent rock. So when the process of formation of soil is at the beginning stage, it shows strong link to parent rocks. But as it keeps get matured and as it keeps getting old, the similarities may fade off. So this is the meaning of the sentence. Also, in case of some limestone areas where the weathering processes are specific and peculiar, soil will show clear relation with the parent rock. So what is telling? The soil may have similar characteristics that show relation with the parent rock. This is the first factor, that is parent material, and this is a passive factor. And the next one, we have topography. What is the topography? It is a physical geography of area where the soil is being formed. And this is also a passive factor. And how is the influence of topography felt? The influence of the topography felt through the amount of exposure of a surface covered by parent material to sunlight and the amount of surface and subsurface drainage over and through the parent material. So it depends on the how much of surface is being exposed to sunlight and also to the drainage. Soils will be thin on steep slopes and thick over flat upland areas. So in the slopes, the soils will be thin, and in gentle lands and flat lands, the soils will be thick. Over gentle slopes where erosion is slow, the perlocation of water is good. So over gentler slopes, the erosion is slow, and there will be a deep penetration of water into the soil also. Soil formation is very favorable. Soils over flat areas may develop a thick layer of clay with good accumulation of organic matter, giving the soil dark color. So over the gentler slopes, they have good perlocation of water is good, and also they develop thick layer of clay with good accumulation of organic matter. So this will result in the dark color of the soil. So this is how topography also influences, and it is a passive factor. And the next one is climate. So climate is an active factor. Unless like parent and topography, which is a passive factor, climate is an active factor. The climatic elements involved in soil development are moisture in terms of its frequency, intensity, and duration of precipitation, that is evaporation and humidity. And the next one is temperature in terms of seasonal and diurnal variation. So what are the two climatic elements involved in soil development? That is moisture and temperature. Precipitation gives soil its moisture contents, which makes the chemical and biological activities possible. So here we have studied that if the soil is too dry or too cold, the biological activity will be slowed down or stopped. So this moisture enhances the biological activity. Excess of water helps in the downward transportation of soil components through the soil and deposits the same down below. So when there is excess of water, it helps in downward transportation of soil components, and it is called alluviation. So what is alluviation? Downward transport of soil components through soil. And what is alluviation? After downward transport, they will get deposited. The soil components will get deposited, and this is called alluviation. In climates like wet equatorial rainy areas with high rainfall, not only calcium, sodium, and magnesium, but also a major part of silica is removed from the soil. So sometimes these rainfall will it helps in removing certain materials, and silica is also one thing that will be removed from the soil in wet equatorial rainy areas. So this removal of silica from the soil is called desilication. So what is desilication? Removal of silica from the soil due to the by heavy rainfalls or high rainfalls. Then it is called desilication. In dry climates, because of high temperature, evaporation exceeds precipitation. Hence, groundwater is brought up to the surface by capillary action, and in the process, the water evaporates, leaving behind salts in the soil. So when the groundwater comes to the surface, the salts that are dissolved in the water also will come up, and when the water evaporates, the salts will be left behind on the surface of the soil. So these salts form into a crust in the soil known as hard pans. So when the salts are left behind on the soil, they form into the crust. So in the soil, and these are called hard pans. In tropical climates and in areas with intermediate precipitation conditions, calcium carbonate nodules are formed. These are also known as kankar. So we know kankar. What is kankar? This is the in tropical climates and in areas with intermediate precipitation, this kankar is formed. This is about precipitation. Now we'll see the effect of temperature. Temperature acts in two ways. That is how? In increasing or reducing chemical and biological activity. So temperature influences the chemical and biological activity. Chemical activity is increased in higher temperature and reduced in cooler temperature. So this chemical activity depends upon the temperature, as how it increases with increase in temperature and decreases with decrease in temperature, except for carbonation. So carbonation is a reverse of all the other chemical activities. If all the chemical activities increase in higher temperatures, carbonation decreases, and vice versa. That is why tropical soils with higher temperatures show deeper profiles, and in the frozen tundra region soils contain largely mechanically broken material. So, and in tropical soils, we see deeper profiles of soil as compared to frozen tundra regions where there will be largely broken materials. And it is also mechanically broken materials, not by chemical actions. And then we have biological activity. The vegetative cover and organisms that occupy the parent materials from the beginning and also at later stages help in adding organic matter, moisture retention, nitrogen, etc. Dead plants provide humus. The finely divided organic matter of the soil. So what happens? The plants and organisms that occupy materials, when they are dead, these help in providing humus, and the finely organic matter will be formed. Some organic acids which form during humification aid in decomposing the minerals of soil parent material. So when the organic acids that come from dead and decaying matter These help in decomposing the minerals of soil, parent materials. Intensity of bacterial activity shows up differences between soils of cold and warm climates. So soils of cold and warm climates have different intensity of bacterial activity. Humus accumulates in cold climates as bacterial growth is slow. So in cold climates, there is humus accumulation because of slowed bacterial activity. With undecomposed organic matter, because of low bacterial activity, layers of peat. So what happened? As the bacterial activity is low, there is no decomposition of organic matter. So what happens? Layers of peat develop in subarctic and tundra climates. So this is in cold climates. But what about in warm climates? In humid, tropical, and equatorial climates, bacterial growth and action is intense. So there is intense action of bacteria in humid climates, and dead vegetation is rapidly oxidized, leaving very low humus content in the soil. Whereas in cold climate, the humus gets accumulated, but in warm climates, there is low humus content because of rapid oxidization of the dead vegetation. Further, bacteria and other soil organisms take gaseous nitrogen from the air and convert it into a chemical form that can be used by the plants. So this bacteria also sometimes take up nitrogen, does the nitrogen fixation, and it will be used by plants. This process is known as nitrogen fixation. And what is the bacteria that aids in this? This is something called rhizobium. So rhizobium is a type of bacteria. It lives in the roots nodules of leguminous plants and fixes nitrogen beneficial to the host plant. So one of the bacteria that does is rhizobium. The influence of large animals like ants, termites, earthworms, rodents, etc. is mechanical, but it is nevertheless important in soil formation as they rework the soil up and down. So what these large animals do? They help in mechanical work. So they try to till the soil, which can help in the soil formation. In case of earthworms, as they feed on soil, the texture and chemistry of the soil that comes out of their body changes. So these earthworms, they feed on the soil. Due to this also, the texture of the soil changes. And the next factor that determine the soil formation is time. What is time? The time is the third important controlling factor in soil formation. The length of the time the soil forming process operate determines maturation of soils and profile development. So as long as the more time it takes to the maturation of soil, the more time it takes to operate the formation, the more maturation we can see in the soil and also profile development. A soil becomes mature when all soil forming processes act for a sufficiently long time, developing a profile. So when these processes are applied for a longer time, the soil becomes mature. Soils developing from recently deposited alluvium or glacial till are considered young, and they exhibit no horizons or only poorly developed horizons. So what happened? When the soil is developing from recent new alluvium or glacial till, they exhibit no horizons, and these are only poor developed horizons. No specific length of time in absolute terms can be fixed for soils to develop and mature. Why is it? Because it depends on so many factors, including time, like biological activity, temperature. So we cannot fix a specific time for the soils to develop and mature. So this is about the factors that influence the soil formation. Under that, first we have studied parent material, that is passive factor, and then we have studied topography, which is also a passive factor. And the next three are important active factors from that influence the soil formation. Therefore, with this, we have concluded the chapter 5, that is geomorphic processes. Under we have studied in detail the endogenic processes, exogenic processes, and the erosion and deposition, and the types of landforms that are a result of erosion and deposition will be studied in the next chapter. So with this, we are concluding this video. If you think the video is beneficial, please like and share the video. Jai Hind.